Question 3 says, find the equation of the normal to the curve y equals x cubed minus 4x squared plus 7 at the point 2 minus 1, giving your answer in the form ax plus by plus c equals 0, where a, b, c are integers. Now, integers, remember, means whole numbers. If you've got to find the normal for the curve, the first thing you've got to do is differentiate. And that means you need to find dy dx. So remember, what you do here is you knock 1 off the power, so that becomes a 2, and the power comes down the front and multiplies by what we've got. So you differentiate x cubed, we get 3x squared. If I differentiate this one, the power on the x goes down by 1, so that becomes a 1, and the 2 is multiplied by the 4, so I get 8. So I get 3x squared minus 8x to the power of 1. Remember, x to the power of 1 is just x, so it's 3x squared minus 8x. Now at my coordinate, which is 2, 1, not minus 2, but 2, 1, the 2 is an x number. So I now substitute that x number into here, and I will get the gradient of the curve at that point. So I get 3 lots of 2 squared minus 8 lots of 2. I've just replaced the x with the 2, which I got from the point in the question. So that's 3 lots of 4, take away 16. 12 take away 16 is minus 4. So that tells me the gradient of this curve at that point is minus 4. So that would mean the gradient of a tangent at that point would be minus 4. But I am asked for the gradient of the normal. And the gradient of the normal is always minus 1 over the gradient of the tangent. So here it's minus 1 over 4. And that's just the same as minus a quarter. So I've got my gradient I'm interested in will be, sorry, that's minus, that tangent here should have been minus 4, so that's my mistake. Minus 1 divided by minus 4, that'll make it plus 1 quarter. So the gradient of the normal is plus 1 quarter. So I'm looking for a straight line with a gradient of a quarter. Well, straight lines are like y equals mx plus c. M is the gradient, so I know that is a quarter. And because I have this point, which is 2 minus 1, where 2 is an x number, and the minus 1 is a y number, that works from any point. The only thing I don't know is a c. So I can rewrite this line, substituting in. Instead of y, I can write minus 1, then equals. M is a quarter. And the m is being times by x. And x is 2, and then plus c. So I've got minus 1, a quarter times by 2 is a half, plus c. Now I want to know what c is, so I need to move this a half. If it's a half over here, which means it's a positive a half, if I move it to the other side of the equals, its sign changes. So it's a minus a half. And minus 1 minus a half is minus 1.5. So that's what c is. So I can write my equation down now. Y equals m times x plus c, which is minus 1.5. Now at the moment it's not written in the right way, because the question said I had to have it written as ax plus by equals c, or sorry, plus c rather equals 0, and everything had to be integers. So what I need to do first of all is get rid of the fractions. Because the biggest number on the bottom is a 4, I'm going to times now every bit of this by 4. Y times by 4 is 4y. Then after my equals, 4 lots of 1 quarter x are a whole x. Then over here, a plus and a minus together make a minus. And 4 lots of 1.5 is 6. So I get 4y equals x minus 6. But the question said I had to write it down as ax plus by plus c equals 0. So let's have a look. I've got my y at the moment away from my x. So what I need to do, I'm going to move that y, 4y, to the other side of the equal sign. So I'm going to leave those bits where they are. That will leave me with nothing on the left. And that 4y when it goes onto the other side, its sign will change and it will become a minus 4y. So if we look at what I've got here, I've got x, 1x, and my by, well that's my by, where b is a whole number, and then I have my number on the end equals 0. So that is what I'm looking for. The 1 here is optional, you don't have to write it in. You could write it as x minus 4y minus 6 equals 0. That is the answer we're looking for in question 3.